talking to you guys a little bit about tidyverse using R. I prepared a short presentation on previous figures I've made, and I thought that we could go over how I coded to create these figures, primarily using ggplot. So just a quick overview of ggplot. It's a package for R that is based on the grammar of graphics, and it basically means that we're building graphs from the same three components. So a data set, a coordinate system, and then geoms, which are basically geometries or the way that we show our data. So here in the green images at the bottom, we can see that we have our data, usually in a table format. And here the geom are points, so those gray circles. And then we have the coordinate system, so our X and Y axis to create the plot. And then at the bottom, we see that those points get like purple, not blue. And then we can choose, so those are the aesthetics. So we can choose the color, the size, or where the circles are shown in the plot. In my experience so far, I really, really liked using ggplot because I can create reproducible graphs, which was really helpful with my thesis because we were getting data, like waves of data. Like every day we were getting new data points from the pediatric surgery. So every day I could click run and I would get the figures already made. And it was really cool to see how they would change with each wave of incoming data. So then this code here at the right is basically a framework or just that base code of what we need to create plots using ggplot. In the dark green, we have the three main components. So first, we have to give our data, then the geom function, which are a lot of different geoms that you can use. So like geom point, geom line, geom bars to show the data. And then in the aesthetics, we choose the X and Y coordinates of where we want to show our data. And then after that, you can basically personalize how you want your plot to look like with all the other functions. And the way I think about it, which has been really helpful, has been thinking about this like layers. So which each line of code, you're basically adding a layer on top of the other. And this image, which I think Dr. Green showed us in our class, in our tidyverse class, was really helpful to think about when building our plots. So we have our data, which is at the bottom, and we're basically transforming that in our plot with our, so let's say our variable A, we're putting it in the X-axis, our variable B in the Y-axis. Then we're choosing our geoms, or geometries, or lines, points, bars, whatever we want. And then from that on, we basically personalize our plots. Do we want any other statistics to show, the theme, how we want the colors or a graph to look like, etc. So what I was thinking that we could do is show some previous figures and then just switch to R and see code by code how we create these figures. And feel free to stop me at any point if I'm going too fast as well. So this was a figure, a multi-panel figure we submitted on a paper last week, but we were looking at global childhood and adolescent cancer outcomes based on conflict status, on countries' conflict status. So if we look at panel A, here we have the new number of cases of childhood and adolescent cancer cases over the last 30 years. And each color represented the conflict status. So did those cases happen in a country facing war? That was dark red. Minor armed conflict in the light red, and then non-conflict in blue. So now I'm going to switch to R to see how this code was built. And something that has been really important for me, and I've learned the hard way, I think, is getting the data set ready to go to the ggplot. So by that, I mean getting one column for each variable that I want to show. So in this graph, we have in the x-axis years. So getting a column for the year variable in the data set. Then the incidence number was the y-axis, and then the conflict status was the color. So basically, this is like the first 6 rows of the data set, but having it ready to just go to the ggplot is really helpful. Another thing is having the right type of data for each one of the variables. So for year, in this case, even though it's a number, it's important to have it as a factor, because it is acting basically as a category in the plot. So after that, the first two lines is this where we're giving our data set. So it's called data in this case, the X and Y coordinates. And then the geom that we choose here was geom col. The color for the columns will vary, or the fill of the columns will vary by the conflict variable. So here it was called conflict intensity, and we give that in those first lines. So R basically has a default way of giving, or the theme that it gives to the graphs with its colors and the background color. But there's many different things that we can do to make it and personalize it. So I usually start by changing the name of the axis. So here we didn't, since we were showing years, here they overlap a little bit, and we're going to change that later. But we wanted to remove the label for year. And then for the incidence number in the y-axis, we wanted to change that because this was in the thousands scale. So we wanted to specify that, which we can do here. So then, since the years were overlapping, we decided that we wanted to only show every 5 years. So starting in 1990, then going to 1995, 2000, etc. So we did that by saying, okay, scale, the x-axis, in this case, is a discrete variable. So we specify that here. And for the labels that we want to show, we created this function where we say, if X takes any of these values, so any of the values of the years that we wanted to show, then it would show it. I got to be honest here, and I asked ChatGPT's help to create this line of code because I wasn't sure how to do it, but ChatGPT is really helpful in creating this codes on the layers once you're personalizing your plot. So now we see that the years are not overlapping with each other, and we have the years that we wanted to show. So then for the y-axis, we wanted to create a multi-panel figure, and we wanted to have the y-axis the same across all figures. So here we wanted to have the limits from 0 to 475, but show increasing numbers in the 100. So 0, 100, 200, up to 400. So the lower value is 0, the highest value is 400, and then increase for every 100, which we can do in with this code. So I think it won't change much because this was the first one we did, but for all the other ones that had different heights of the bar plots, it changed. So then for the fill, for the colors, and this is one of my favorite parts when I start to change the colors of everything. Since we choose scale and then fill, because this is what we had chosen here, this is the fill. So we have to match it to what we want to change it to. And then I chose hex colors. And I found a very useful tool to choose colors. Let's say I'm reading an article that I really like the colors from the figure. You can choose, there's this extension for Google Chrome that you can add. It's called the color picker. But let's say you're in this website and you like this blue. So you can select the hex color that you like and just copy it and paste it to R. Let's say this article too. So here it's a PDF. This tool works a little bit different for PDFs. It kind of takes a screenshot of the image. But it still works the same, where you can choose the hex color that you really like and add it to your plot. So going back here, this is how I chose these colors from our article, and you can specify them here in the plot. Okay, so then R has different default themes. One of them is theme minimal, and it's the one that I probably use the most. This one, the theme minimal, removes this gray background of the figure and changes a little bit of the setup of the breaks in the axis. So now we see that the gray background is removed and the grid lines are a little bit lighter. But we wanted to, wait, actually, I just remember, I had it broken down here, but we wanted to remove the gray grid lines and we can do this with this code in the theme. So panel grid minor and major, which we could do here. Let me see. And then here, this code, axis title Y, we wanted to change the size of the letters and add some margin between the title, the Y axis and the numbers, because usually R puts the titles and the numbers of the axis very close to each other. So we can increase the space in between that with margin R, because it will be to the right of the axis. And then you can play with this number. I've put 15, but you can play if you want more or less space in between those.
Pamela, there's a question for you
Yes.
here.
Oh, yeah, sorry.
Go ahead.
Thank you. Pamela, very cool. How did you add the hex extension in Chrome? Is that a simple download?
Yeah, so it's called, I think there are multiple ones, but you can, it's called color picker. Let me see. I don't know if you can see the window. It's color pick eyedropper. And I have a link
Sweet.
to the, I can share the slides at the end too, but I have a hyperlink to the Chrome web store where you can add the, since I have it added here, but I think there's like, it would say add extension or something like that in this button.
Sweet.
Cool.
Thank you.
You
Of
could
course.
just as well drop the link in the chat and we are good to go from
Oh,
there.
yes. That's a good idea. Let me try to go real quick and add it here.
You can go ahead, Pamela. We'll drop the link. Find
Oh,
it and
okay.
put there in a minute. Oh, there it
Perfect.
is. There you go.
Great. Cool. So any other questions? Okay, perfect.
Nope, keep going.
Okay, great. So then again, we wanted to keep changing the sizes and the colors of our titles in the graph. We can do it with axis text. This will change the size of the text and the color. Then the axis text X will change the number. So the number of the year, so 1990, 1995. We wanted to give it an angle. So if you look at the figure here, we had it at a 45-degree angle for the years. So you can specify that with axis X here, axis text X, angles equal 45. And then the vertical and horizontal justification will help so that the numbers are not overlapping with the axis. So by choosing one, I believe it give it more space. But again, these are numbers that you can personalize and change depending on how much space you want between the bars and the numbers. Then for the y-axis, we didn't want an angle, we want it to be 0, and then add a little bit of space between that and the plot. We wanted to add a little bit of margin around the plot, so we can also give that each number, it's like, I don't remember the order, but it's the high, the upper margin, the lower margin, the right and the left. And then since we got rid of the grid lines here with this code at the top, we want to bring it back, and we can do that by putting axis.line and then the element line and the color that we want. The same for the ticks. So for each year, we want it to have this black ticks in the axis. So we can put it back with axis ticks element color black. And then we wanted to get rid of this legend title or the variable name that says conflict_intensity on top of the colors of the legend. So we can do that with a legend title element black, which is usually the way to remove things under the theme function. So if we run everything, we should get to a figure that looks pretty much like the figure that we had here. And to create the multi-panel figure, I basically run a very similar code for the other variables and then exported it as a PNG file. I personally, to create multi-panel figures, try using other softwares other than R, like Figma or Illustrator, just because it gives me a little bit more freedom in how I want to set up the multi-panel figure. But there are also ways of doing facets using R if you prefer that. But here you can also, a lot of journals require a specific quality of the image that you export, which is usually the 300 DPI. And you select the format that you want to export the image here. So .png would create a PNG image, but you can also do TIFFs file, SVG, and then you can choose that depending on what the journal wants a figure. I know the last journal I submitted last week for these figures was SVG, which is a vector-based image, but it's really cool because it gives you the freedom to choose whatever you want to use. So going back to the figures, now we have another option, which is line plots. So this was for the same paper. We were looking at global childhood and adolescent cancer mortality rates. And we calculated the median cancer mortality rates for each one of the groups. So for conflict and non-conflict countries. And we showed in the shaded area around the line, we show the IQR since we were calculating the median of the point. So I'll go back to R, where we have the code. First, getting that data set ready for the plot. So here again, in our x-axis, we had the year variable as a factor. Then we have the median, which will be our y-axis, our Q1, which was the bottom of that shaded region, and then the Q3, which will be the top of the shaded region. And then the colors would be determined by the variable conflict status, which was a 0-1 variable here. So this one is interesting because here it shows that we can have multiple geoms to create the graph. So the first one, we have a line. So we have the data, we specified the data set, the coordinate system. So X will be year, Y, the median death rate. And then the group or the color will be based on the conflict status. So the first one, R, gives its default colors, its default background color and everything. But then we can also add a second geom to add a point for each one of the values for every year. So in 1990, we wanted to show a dot where exactly that line was falling. And we can do that with a geom point, again, specifying that we wanted the colors based on the variable conflict status. So here, if we run that, we see that it adds a point for each one of the years. Then we wanted to show that IQR around these lines to show that the spread of the variable. And we choose again, in this case is fill because we're filling that shape based on the conflict status variable again. And then alpha determines the transparency of the colors. So it ranges, I believe, from 0 to 1. In this case, I wanted to be very transparent. So I went down to 0.15, but I can play with the color to see how it looks like a bit darker. So this is about 15% transparency, but if we go to like 70 or 0.7, it goes a lot darker. And since these are layers, and this is the third layer, so we have line, point, and ribbon was the third layer, we see that it goes basically on top of the previous layers as we were adding them up. So here. So now the same way, the next step, I usually do re-add the labels of the axis and the same function that we had in the previous plot to only show the years every 5 years here for the X scale. So now we have the years a little bit, the X scale a little bit more clean. And for the Y scale, we chose the we set the limits because again, we had a multi-panel figure for this. And by selecting the breaks here, we choose the tick mark. So right now we have it 4, 6, 8, but we wanted to match the other figures as well. So we manually selected those breaks as 5, 7.5, 10, and 12.5. Then with the scale color, we're choosing the color that we want to give to the conflict status variable. So R already has some colors that you can type in, like predetermined colors. Black is black, but for example, For blue, it has a predetermined blue shade for that. There's some like red, they're just basic colors, and it has that shade of red. But because in this paper, we wanted to keep the same shades of red across so it would match, we added the hex color that we had already selected in the previous figure here, but the black was just easy because that's what I already had predetermined. Then in the labels code, we choose how we want to label each one of the colors. This was a factor that we had selected previously as conflict or non-conflict. So 0 was non-conflict, 1 was conflict, and we can give it a name here with the labels line here, and then the name is for the title of the legend. So right now it's conflict underscore status, but we can delete that by adding just empty quotation marks here. And we did the same for the fill scale, which is basically the shaded region around the lines. We give the black color for non-conflict and red color for the conflict status. And we didn't want to have a title to the legend there. So it removes the title here, but we still have this. Oh, sorry, I didn't run the code here for the fill. But it removes both titles, but we still have the legend for 01 for the fill. So the way to get rid of that is by typing guides, fill, since this was the fill code that came from here at the top. So guides fill equals guide none. And this will remove the legend title and the legend itself. And the last step was choosing the theme overall. In the previous one, we chose theme minimal, and this one, we liked a little bit how this theme black and white looked like. So we added that at the end, and as you can see here, this theme black and white adds kind of this square around the black square around the plot, and we just decided that looked nice, so we chose that one for this figure. So I wanted to show you this example. So this is the same base code for this figure, but now instead of looking at conflict status, we're looking at performance in this governance indicators with the same cancer mortality rate. But it was just a multi-panel figure using the same codes where I pretty much only changed the fill variable and then the colors with instead of the red, we changed it to blue. Okay, so now the third figure is maps, and this is something that I discovered recently and has been really useful for mapping and basic maps. So this was used for a systematic review. We were looking at the prevalence and incidence of congenital anomalies around the world, and we thought it would be cool to show where these papers were coming from. So the papers that were included in the systematic review, since we were using these rates to estimate global incidence and global prevalence. So showing where these papers were coming from would be helpful to know where these estimates also were pushing it. So the United States is the highest country, well, the country that had the most papers, and then we saw Africa didn't have a lot of countries, but this was something that the reviewers really liked. And I think it's a good alternative to ArcGIS or other mapping tools that can be a little bit more complicated at the beginning to learn with, but especially for me when I was starting this gave me a good way to map this quickly. So here R already has like a data set with the coordinates of the world. I think it's the projection, the WGS 84, I believe. And you can load that map data by saying map underscore data and then in parentheses world. And it has, let me code it so maybe we can look at it real quick. But it has the longitude, latitude, and the countries are under the variable region. The group, I believe, assigns numbers to the country. So Aruba is group 1 and so on. But then, and this is behind the scenes, an important point here is that you have to match the spelling of the countries to the spelling of the countries is in your own data set. So I'm not showing it here, but I basically did an anti-join between my data set and the data set from R to see what countries didn't match. Let's say maybe Aruba is not the best, but let's say Russia. In my country list, it was Russia, but in the R data set, it was Russian Federation. So I made sure to match those spellings so it would match all of the countries when joining to the two data sets. Luckily, in this data set, I didn't have a lot of mismatches, and my data set was an Excel file, so I was able to change them directly in Excel. So I could see how this could be an issue if there's a lot of mismatches. So this could definitely be the downside of using R to making maps. But once you get over this, I think this is the entire code that you need to the whole map. So I feel like it was really helpful once you get over that step. But to make a map, you use the ggplot, you call the join data set. So in this case, the variable that I added was the last one, so %, and all the first columns were the ones that the R data set already had. So it's the map data, the longitude would be our X, the Y would be our latitude, and then group would be our countries or the group variable. And this line of code, I'm pretty sure I got it from Stack Overflow or somewhere that showed me that group would be what we needed to group kind of those countries together in the map. Then the geom that you need is geom polygon, and which will basically create the black lines for each one of the countries in the map. And in this case, my variable of interest was %, which was a % of papers in the systematic review that came from that country. So here my variable was a number. And then color equals black will be the line of code that will choose the color of the lines that we want to show for each one of the countries. So these are the default colors and themes, that has when you run these lines of code. So it's blue and it's showing the latitude and longitude and the x-axis. So we can get rid of all that later. So since the % variable was a continuous variable, we can see it here in the legend. So it is basically a scale of colors, not like the other ones where we had categories. We basically have a scale now. In this case, R already has some or default scales that we can look at and choose from. In my case, I chose this one, and the way to look at all of them, I think you need to load this package first, library R color brewer. And after you load it, you can run this code, display.brewer all, and it will show all of the default palettes that R has. Let me give a second. So here in this case, you can see them here. We chose the second one, the YLORBR, a palette for our colors, and this is where we put it. So scale fill, since this was the fill code that we gave here, we say scale fill, distiller, and the name of the palette. Originally, this palette had yellow for higher values and brown for lower values, and we wanted to flip that because we wanted lighter colors for lower numbers and darker colors for larger numbers. So you can change that by typing trans equals reverse. And then for NA values, we wanted to show it white. So you can also choose that here. Which,
Pamela, there's a question from Abali.
oh yes, go ahead. Sorry, I cannot see who has
No
it.
worries, Pamela. Thank you very much for this very interesting and enriching presentation.
Of
So
course.
just out of curiosity, I'm just wanting to know the percentage of manuscript, was it as a function of the total number?
Yes.
Okay.
Yes.
Thank
So
you.
that we had like 100 papers, a little bit over 100 papers, and about a little bit over 30 came from the US, for example. And that's why they're color brown here.
Okay.
Yes, thank you for the question. Okay, so now that we have the colors that we wanted to get rid of the X and Y axis where it says long and latitude. We want to get rid of the gray background and those grid lines. So we do that in the theme code. So here axis line equals element blank. Basically, everything that goes in the theme function and that you want to get rid of, you choose what you want to get rid of, followed by element blank. So we'd see it here for the axis lines, axis text, axis ticks, axis the titles, the panel grids, the panel border, the panel background. So with all of those, I follow with the element blank and get rid of them. Then the legend title, I wanted to make the size bigger, and for the title, I wanted to make it bold. So use face equals bold, and that would make it bold. And then for the legend text, I also changed the size because I want to make it bigger. So we run that, and oh, I didn't highlight here. And then that gets rid of all of the longitude, latitude stuff that we had in the background, and also those changes to the text in the legend. And then the last thing was that the 30, so the higher value was at the bottom, and the 10, the lower value was at the top, and you wanted to flip that. So you do that with this last line of code, which is guides equal fill, and then the guide color bar reverse equals true, which would basically reverse that order. And that's it to get to the map. Okay, so then the last figure, which was scatter plots, this figure was very useful for the exploratory phase of this paper. It's, again, global childhood cancer survival rates at the country level. So we had all the countries, like a lot of countries in the world. I don't remember the total, but it was close to all of them. And we wanted to see, based on different variables, how they impact survival at the country level. So here we have GDP per capita, but we had education variables. We had health system variables like number of pharmacists or pharmacies in the country. And then so we would change the variable in the x-axis and then see how the survival would vary in the y-axis. And then in the colors, we have the World Bank income levels, because we wanted to see if there was any relationship with that. And we would identify through clustering of those colors visually, just the exploratory phase of this project. So in R, the scatter plot, again, getting that data set ready, we have the GDP was their x-axis, the survival was the y-axis, the income level was the colors, and then we had the country, the 3-letter country code to show next to each one of the points in the plot, like here. So we give our data set the y and x-axis variables, and then we wanted to show the points. So geom point, the color of those points you wanted to vary based on the income variable, and the size of those points, we also show it here. We can also play with those numbers. Right now it's in size 3, but let's say I could put it in size 5 and see how that changes. So it increases the size of those points. So let's go back to 3 to show how that looks like again. So it's a bit smaller. So then to add on the 3-letter codes next to each one of the dots, we have the geom text repel. And we want to show the label is based on the variable country code that we have here. And again, we wanted the size about 3 to match the proportions of the size of the points. The next line of code is the labels. So the x-axis label, the y-axis label, and the title for the legend, which is the color here, has to match what we had said in the aesthetics here. So if we do that, It should change the titles of the legends to what we want. And then again, we choose the colors. So since the aesthetic was color, we say it's scale color manual because we're manually selecting those colors. And this is another example of colors that are already recognized or has a specific shade for it. So dark orange is this color, purple is this shade of purple. And I like those colors, so I chose those. And you can just type them with the quotations and it changes them. Again, I really like the theme minimal. It gets rid of the gray background, and we'd see how that changes the plot by typing theme minimal like this. And then lastly, we wanted the legend to be at the bottom of the graph in this case to give it more space for that, because it was a wide plot, or want to have more space. So we moved the legend to the bottom, and you could do that again in the theme function, legend position equals bottom. I think the default is this one, so it will be right. And then the axis title X, we wanted some space again because it was really close to the axis numbers. So we can add for the X axis at the top, that's why the T is there. So T equals 20. And then to the right of the Y axis, again, 20. But you can select the number that you prefer to add on more or less space based on your preferences. And this is how the graph ended up looking like here. And then lastly, I'm not going to go over the code for this ones, but I thought this was I saw this type of plots in a paper and I thought they were fun and different to look like. This graph comes from the same data, from this data. So we have in purple, lower middle income countries. And what we did was calculate the mean survival for these purple countries. And what we wanted to identify was positive and negative deviance. So countries that were performing above the mean or below the mean for this specific group. So for lower and middle income countries, we chose the top positive deviants, which are the ones above the mean to the right, and then the negative deviants, which were the countries going to the left. So just wanted to show you this brainstorming ideas. I don't know, maybe you might have projects where you want to show deviants, positive and negative deviants. Thought this would be an interesting and different way of visualizing this. And we did the same. We created a multi-panel figure here for low income, lower middle income, upper middle, and high income countries to see those differences at the country level. So here, I just wanted to finish with kind of a workflow and just share some resources of what I usually do when making graphs in R. I look for examples in scholarly articles, in World Bank or WHO reports. I kind of steal those colors with the tool, with the extension that I showed you guys, if there's any color that I particularly like. There's also a lot of data visualization blocks that I found really useful that can help in choosing colors. So this one, it's called Block Data Wrapper, and I can share the link in the chat as well. But here, for example, this one is emphasize what you want readers to see with color. So a lot of the time, you can use play with grays and add color to the line that you want to highlight, for example. And this I've seen a lot of people do to show their data and show readers what's important in that plot. But overall, I think the data wrapper block has been really helpful just to help and honestly choose colors that look good. Also the size of the text and everything. So they have, this blog has a lot of really good resources when choosing and creating plots. Then, as I said, the hex colors with the Google Chrome extension, as I showed here, you can choose, I don't know, the color that you want and get the hex color. And then the names of palettes that R already has, you can either code that as I show you, or just Google R colors or R color palettes, and there's links or websites that show that, and you can see all the palettes. And then when I'm writing my code, I usually use Stack Overflow, watch YouTube videos, or use ChatGPT to help me troubleshoot or edit that code and say what I want or what I want to change. Because there's definitely a lot of ways of achieving the same thing. So these are resources that I find really, really helpful for that. And then also checking the journal guidelines to see what bigger format I need. Is it PNG? Is it TIFF? Is it SVG or whatever file I need for the final image? And this, my personal preference, as I said, at the end, giving those final edits primarily for those figures with panels, I do it with Illustrator or Figma. And then the last thing that I can also share the slides with is this tidyverse cheat sheet, which is from our studio. And as you guys saw, there's a lot of options of what geoms you can choose, and that can be really overwhelming. So this is a great resource to see all of the possible, like all the possibilities that you have when creating plots. So here in the geoms box at the bottom, we have when we have one variable continuous, what geoms you can choose. When you have two variables and both are continuous, what geoms you can do. When you have one discrete, one continuous, or both discrete. And it could be a great resource when you're starting, or even I really refer back to them when I'm brainstorming on how I want to show the data. And then the second page of this cheat sheet has a lot more on the scales that I was showing. If you have a X, Y continuous, for example, or the themes. So I mentioned that I chose the theme minimal a lot, but there's definitely a lot other themes that you can choose from. And here it gives you a small preview of how that theme looks like. But I think this is all I had for you guys today. So I don't know if there's any questions, and happy to share all these links in the chat as well.
Thank you, Pamela, very much. This is great. Yeah, you gave me some remind memories of when I was working with R many years ago, figuring out ggplot and trying out these codes and just the plot doing something that I liked that I couldn't replicate. So
Yeah.
you went through the details. That I like the way you talked about the layers and how you can build out the layers. So very, very interesting. So thank you for
Perfect.
sharing that. I also can help myself but notice from your RStudio that you have one template for all of them. I would love to transform this into something that we can plug and play
Yeah.
and have it as part of the library of resources, along with the other things we're planning to do in December. I think it just builds out a resource library that's great for everyone. Yeah.
Yes, that would be super helpful and saves a lot of
Yeah.
time too. But it's definitely
Agreed.
a learning curve using ggplot. So yeah, don't
Yeah.
get too overwhelmed.
Well, make sure you keep, whenever you build a template, it would be great to keep your name as the author so that we can give it just recognition to who created that at the time and people can use, but we want them to acknowledge that if there's a case. We can build, that's part of what we're going to build out with this initiative. But
Yeah,
at the same time, it's fantastic work to look very beautiful. Thank you very much.
Thank you. Thank you.
Cool. Any questions for Pamela? Nope. All right. Well, we asked questions as we went, so that's very good.
Great.
Okay. So I think we can stop recording now.